Something is happening on Pluto right now. Every second, part of its atmosphere escapes into space. But it isn't simply disappearing. Somehow, that material is ending up somewhere else, and figuring out where. It goes led scientists to one of the strangest discoveries in the entire solar system. What makes that discovery so difficult to explain is that Pluto was never supposed to be active at all. Nearly 4 billion miles from the sun, scientists expected a frozen, silent world locked in deep freeze. A place where nothing changed and nothing happened. Yet the farther researchers looked, the more Pluto seemed to break the rules. Somehow, Pluto's atmosphere seemed to be breaking rules that worked almost everywhere else in the solar system. Evidence suggested this distant world was far more dynamic than a body that cold should be. Then humanity finally got its first close look. When the New Horizons spacecraft swept past Pluto, it found enormous mountains, vast plains of frozen ice, and signs that this forgotten world might still be changing today. For a world that should have been frozen in time, Pluto looked surprisingly alive, and yet none of those discoveries explained the biggest mystery of all. If Pluto was losing part of its atmosphere, where was it going? When New Horizons finally reached Pluto, scientists expected to find a frozen world preserved in time. Instead, they found evidence of change. Towering mountains and surprisingly young landscapes suggested Pluto was far more active than anyone expected. That was a problem. Dead worlds accumulate scars. Active worlds erase them, and Pluto seemed to be erasing them. The discoveries suggested Pluto wasn't simply preserving ancient features. Somehow, parts of this distant world appeared to be renewing themselves in one of the coldest regions of the solar system, and that raised a troubling possibility. Could whatever was reshaping Pluto also be connected to the atmosphere mystery scientists were trying to solve? Its atmosphere. Pluto wasn't just breaking expectations on the ground. Its atmosphere seemed to be breaking them too. And while scientists were trying to explain Pluto's surface, they realized an even stranger mystery was unfolding overhead. Its atmosphere was doing something nobody had predicted, and the more scientists studied it, the harder it became to explain where all that escaping material was actually going. The more scientists studied Pluto's atmosphere, the stranger it became. By now, researchers had accepted that Pluto wasn't behaving like a normal frozen world, but its atmosphere turned out to be even stranger. High above the surface, layers of bluish haze stretched through the sky, forming an intricate structure unlike anything scientists expected to find so far from the sun. At first, those hazy layers didn't seem particularly important. Then researchers realized they might be changing the atmosphere itself. Evidence suggested the haze was helping Pluto lose heat far more efficiently than expected. Somehow, one of the coldest worlds in the solar system seemed to be cooling itself in a way scientists hadn't predicted. The farther researchers looked, the more Pluto seemed to resist explanation. But the haze created an even bigger problem. If scientists were misunderstanding how Pluto's atmosphere worked, what else were they missing? That should have been the end of the story, except it wasn't. Because the more researchers analyzed the data, the harder it became to explain one unsettling fact. If Pluto was losing all of this material into space, where was it ending up? For years, scientists assumed the material escaping from Pluto was simply being lost to space. It seemed like the obvious explanation. Pluto's gravity is weak. Its atmosphere is thin, and molecules can gradually drift away into the darkness beyond the dwarf planet. But as researchers collected more data, that explanation started to look incomplete. The mystery deepened when scientists noticed something unusual elsewhere in the Pluto system. On a nearby world, strange reddish deposits covered large regions of the surface. At first, the discovery seemed unrelated. There was no obvious reason to connect those reddish materials to Pluto's atmosphere. Yet, the timing was difficult to ignore. The same system that seemed to be losing material into space also contained evidence that some of that material might not be gone at all. Suddenly, the mystery wasn't just about Pluto anymore. The pieces didn't fit together yet. But researchers began considering a remarkable possibility. What if the material escaping from Pluto wasn't being lost at all? What if it was being captured? If that idea was correct, it would mean Pluto wasn't simply shedding part of itself into space. It was sending it somewhere, and the identity of that destination would completely change how scientists viewed the Pluto system. The answer was hiding in plain sight. Those unusual reddish deposits weren't just random features. Scientists eventually realized they could be the missing piece of Pluto's atmosphere mystery. The destination wasn't empty space. It was Pluto's largest moon, Charon, Pluto's own moon, after all the theories, observations, and unanswered questions. The missing material wasn't disappearing into deep space at all. It was ending up on another world. Researchers believe some of the material escaping from Pluto drifts across the Pluto system before becoming trapped by Charon's gravity. Over time, sunlight triggers chemical reactions that transform this captured material, leaving behind the reddish regions scientists observed on the moon's surface. In other words, part of Pluto's atmosphere may be helping reshape another world. Every second, tiny traces of Pluto begin a journey between two worlds. Over immense stretches of time, that transfer may have helped alter the appearance of an entire moon. The atmosphere wasn't simply disappearing. It was traveling from one world to another, and that realization changed how scientists viewed the entire Pluto system. Instead of a frozen relic at the edge of the solar system, Pluto appeared to be part of an active and interconnected environment. More importantly, it raised an even bigger question. If a distant dwarf planet can exchange material with its moon and remain far more dynamic than expected, how many other hidden worlds are doing the same thing right now? And if Pluto was this surprising, what else have we completely underestimated?